This is my submission to assignment 2. First, we have the linked list. So firstly, we would have, I will run, this is the code for our double linked list. And then I will create the alternation interface using our double linked list. So firstly, we'll initiate this class with a double linked list, and we have a pointer named Kurt. Firstly, it's pointing to the head of the double linked list, and then if we go to the do operation, if the double linked list is empty or we are now at the latest page of the history, we'll just add the operation to the append the operation to history using the append method from the double linked list, and then we pointed our pointer to the tail of the double linked list. Else, we would have to insert a new node. So firstly, we will have to using the current pointer, use it at the tail of the double linked list, and then we would have to add a new node, the new operation, append to the tail, and then remove rest of the history, and then we appointed our current pointer to the new operation, and undo will just going back from the along the double linked list using the current pointer. If we don't have any pages back, we'll print it cannot be undo. Redo will be we are going along down the operation history, just going to next of the current pointer. If we cannot reach if there's no next, then we'll print it out. And then we have the method print current status, which is we will print the current status of the operation. And if we don't have it, if now we don't have it, we'll print the status not available. And then we are going to do the following actions as assigned from our homework. So firstly, we're gonna create a list. We firstly use the do. We use a list, and then we print the status. So we have the original list, and then we will sort the list. We'll do the sort list and then print the status. This is the sorted list, 1, 2, 3, 4, 5, 8. And then we'll reverse it. We have the 8, 5, 4, 3, 2, 1, and then we'll add 9 at the end of the list. We'll just add 9 and then do the new list and then print the current status. So we see a nice appended. And then we want to undo back to before our reverse list. So this will request the 2 undo operations. So we did 2, and then we printed out the current status. So this is the sorted list. So this is the 1, 2, 3, 4, 5, 8, and then we will append a 9 to the end of the list again. So we will now have a 1, 2, 3, 4, 5, 8, 9, and then we want to undo back to the original states of the list. So we again here we do undo twice, and then we're back to the original status of the list. Okay, and then we have the second task. This is stacks. So we are using a linked list structure. Here I'm using the single linked list to implement the stack, and then this is how I create my stack. So firstly, we'll initiate a single linked list, and then so we'll look at, firstly we have the is empty. So we're gonna return if the head is empty. If the head is empty, then this is none. This is empty. Then we have the push. So push will just create a new node, and using the new node next pointed to the head of the current single list, and then we will assign the head the new node to be the head of the new single linked list. And then we'll have the pop method. Pop will be if the single linked list is not none, so it's not empty, we'll just assign a temporary value for the head of the current single linked list, and then we would we will move the head to the next of the head. So, and then we will return the temporary value as the popped out. Pick is pretty much the same. We're gonna if the stack is not empty, we will or the single linked list is not empty, we will just return the value of the head. Else we'll just print the stack's empty. And then we go into the palindrome challenge. So we will use the file palindrome, and then to determine which word is palindrome. So here, firstly, we read CSV, the TXT file using pandas, and then we will turn into the list. And for all the words in the list, firstly, we have to make everything into a lowercase. In case some like uppercase would not be able to match with the lowercase number, the character. And also we have to remove all the spaces in the word. So if there are any spaces here, that will create an issue. Then we'll just create a new stack, and then we push. We would like iterate through the word and push every element into a stack, and then we will just create a new world. Basically, we'll pop all the everything from the stack, and then append them together one by one by order. And this, because stack is first in, last out, this every time we create this, the word, the characters will be coming to a reverse order. Once we finish, we'll have the reversed word. And then we're gonna compare the reversed word against the original word. If the word is same, we're gonna print it out. This is palindrome. Else we're gonna print it out. It is not a palindrome. So as the result show, morning is not, label is palindrome, madam is, and first is not palindrome, noon is, and race car is, and so on until the end. Wow is palindrome. So we have finished the challenge, and then we have our final question, which is not a coding challenge, but we are going to implement discussing about if we implement a remote printing system serving a large pool of individuals using just a simple queue that only support first in and first out operation, and what could be the issues here. So there are some issues I could think about. Firstly is the waiting time of the completion will be very long, because everything is linearly first in first out. If there are many people submitting word requests, even like by order, because it can only like process everything linearly one by one. If there are many people submitting it, it will wait for a very long time. Even though like some task is not finished, you still have to wait it. And the second will be like if there are users submit requests simultaneously, it will be hard for a single queue to successfully take in all the requests. Because once we, if we want to take in the request, if we want to enqueue into the queue, we have to dequeue at the same time. But if like the dequeue is depend on the processing capability of the our system, so it will be apparently that the processing capability might not be able to meet how fast the people submitting requests if during a peak time. So this will cause an issue. And the third one, that will be like once a request is submitted, it cannot be cancelled until it's dequeued from the queue. So we have to wait all the task, requests before the one who want to be cancelled, until we can do any modification, cancel or modify to it. So this will result in like many redundant requests in the request in the queue. So basically, maybe many people think made a mistake. Some people made a mistake, but we cannot withdraw it from the queue. But and the queue like remains the same size, and then you still have to others still have to wait for this one to be processed or to be tagged as or to be dequeued to complete their task. The first will be like you cannot change the order of the request once they are taken in the queue. It's hard to like sort it in the queue. You can only like doing first in first out. But let's say if someone just wanted to print one page, and we still have like printing resource in the system, and but he or she still have to wait for all the bigger tasks to be completed first. Even though there's some like still some space for the task. Thank you.